Welcome to the first flipped Stage 2 chemistry lesson for this year. So this is how I intend to deliver most of the new content this year with these flipped lessons, which is basically with these videos. And then hopefully you can watch these in your own time or in class when I'm working with other students doing other subjects. And then we can spend that time in class really focusing on doing questions and working out where maybe there are some problems with your understanding or trying to enhance your understanding of the subject. I will provide you a PDF copy also of the notes that come from doing these flipped videos. So you don't necessarily need to feel you need to write a lot of notes as you watch the videos. Everything that you see appear on this screen, you will get a copy of in the notes. So the first topic for the year is monitoring the environment. And the first subtopic is global warming and climate change. And I'll divide this, and I'll do this for a lot of the subtopics, up into two parts. In part A, we will look at the greenhouse effect, and that will be what this video focuses on. And in the next video, we will look at ocean acidification. Let's get into it. So firstly, just in terms of the structure of these notes, up in the top left-hand corner, you'll see the science understanding. That's straight out of the SACE curriculum outline. So that's basically for each of these subtopics what SACE is telling us that we need to know. So that's a bit like your checklist for your understanding of the things that you need to know. Then to the right of that and below, and then onto the next slide, I'll really explore in some depth the science understanding here and hopefully help you to understand the really key points of that. Now, if you haven't already checked out this video here, None Like It Hot, please do. I think it provides a really good introduction into the greenhouse effect in really simple terms that hopefully makes it easy to picture in your mind. So, yeah, have a look at that if you haven't already. But now let's talk about greenhouse gases. Now, as you might have seen in the workbook, there is more than just carbon dioxide and methane as greenhouse gases. However, the curriculum outline asks us to focus on carbon dioxide and methane, so I've only really put these essential ones in there, but I don't want to discount those other ones that are in the book. But carbon dioxide and the methane are the two that you do need to most importantly know about. The sources of carbon dioxide, and this does jump a little bit into the second dot point here, but I think it's worth starting here, are primarily from burning fossil fuels in car engines and to produce electricity, and also from deforestation, which basically reduces the amount of plant material available to do photosynthesis, which converts carbon dioxide back into oxygen. Methane is the other primary greenhouse effect. The mining of fossil fuels can release lots of methane into the atmosphere. Farming in both animals and plant farming, so for things like rice as well as for livestock, can result in large amounts of methane through either the decay of material or through those animals, the decay of material in the guts of those animals, which is what comes out in the form of fart gas, for lack of a better term, which is contains lots of methane. And the anaerobic decay of waste. So anaerobic means with no oxygen. So where you get organic matter, so living matter decaying, whether it's in landfill or whether it's in a flooded valley or something, and it's either underwater or buried underground, there's no oxygen present. As that decays, it will release methane gas. In this column here, if we use sort of carbon dioxide as a reference of 1, methane is about 28 times more powerful or a stronger global warming agent than carbon dioxide. So while there isn't as much methane, it's 28 times, if you like, more powerful, so it can have a significant effect. So what is the greenhouse effect? So hopefully this picture here outlines what you would have seen in this video up here in a slightly more scientific manner. So, most of the energy on the Earth comes from the sun, and it travels down into the sun through our atmosphere. Now, a lot of that energy, and the energy we're interested in here is in particular what we call the thermal radiation, or sometimes called the infrared radiation, or probably just best to think of what we experience as heat, what causes heat. About half of that just gets basically reflected back off the planet, and it's never absorbed by our planet, so it doesn't actually have any warming effect at all. However, the greenhouse gases, such as carbon dioxide and methane and water vapour and others, they can absorb some of that heat, some of that thermal radiation that would otherwise be reflected. So it doesn't get reflected back into space, it becomes trapped in our atmosphere. To get an idea of how much effect this has, the Earth would be about 33 degrees cooler without these naturally occurring greenhouse gases, primarily carbon dioxide. So if they weren't there, all that extra heat would be reflected out of the atmosphere, would not be trapped in the atmosphere, and the Earth would be about 33 degrees cooler. The other thing to distinguish between here, because sometimes this causes confusion, hopefully what I've explained explains how greenhouse gases cause the planet to be warmer, because they absorb that heat that would otherwise be reflected and lost from the planet. However, they also help maintain a steady temperature, so we don't get really large fluctuations in our temperature between the daytime when the sun is shining on the Earth and the night time when it's not shining Earth, or between summer and winter when there is significantly different amounts of solar radiation hitting the Earth, or between the equator and the South Pole, which also experience significantly different amounts of thermal radiation reaching the surface. So what happens here is the heat is trapped and retained in the atmosphere by these greenhouse gases. So it acts like an insulator. So it's a little bit like wrapping yourself in a blanket. Those carbon dioxide and other greenhouse gases are like a blanket around the planet, and they basically help hold that steady temperature, maintain a steady temperature by keeping all those greenhouse gases trapped in the atmosphere. So this can cause a little bit of confusion, particularly when you're doing explain questions around this, but I think sometimes it's useful just to think about those two things as definitely related, but as slightly separated. The warming effect is because they absorb them, the maintaining steady temperature is because they are basically trapped in our atmosphere and can't escape, and they act like a blanket around the planet. So finally we're going to look at the anthropogenic, or the man-made effects or influences on the greenhouse effect. So I think, as you probably all know well by now, the burning of fossil fuels and lots of other human activities like farming and use of fertilisers and lots of other factors are causing many more greenhouse gases, particularly carbon dioxide, to be released into the atmosphere. You can see in this graph here, if we look at the, just bring up my pen's gone flat. You can see here from 1880 through to 2016 on this scale here, we've almost doubled the amount of carbon dioxide that's in our atmosphere. So, all these human activities are releasing lots of different greenhouse gases, but particularly carbon dioxide. So the most obvious effect that we're seeing here is an increase of temperature. So the blue line here shows what we call the temperature anomaly. So how much has the temperature changed during that time period? And we can see we've got an increase of about, on average, 1.2 degrees in global temperatures. And you can see there's this strong, what we call correlation between the amount of carbon dioxide and the temperature. As we release more and more carbon dioxide along this white line, we're seeing the temperatures of the Earth also follow a very similar pattern. So the most obvious consequence of the anthropogenic increases in greenhouse gas emissions, if I quote myself up here, is increasing temperatures. The other factor that we need to think really carefully about too is how these increases in temperature due to increases in greenhouse gases and particularly carbon dioxide could affect our sea levels. This graph here shows over the last 22,000 years roughly the relationship between the temperature in red and the sea level. And you can see that there is quite a strong relationship between temperature and sea level. And if you go back 20,000 years, the sea levels were about 120 metres lower than they currently are. So at the moment we're just starting to see some very small increases in sea levels here. But you can see here that we have had a big spike in temperature. So we need to be really aware, is this big spike in temperature that we talked about previously going to also, down the track, have a big effect on our sea levels? Increasing temperatures due to the enhanced greenhouse effect, or the anthropogenic increases in greenhouse gas emissions, is also causing things like the melting of the polar ice caps, particularly at the Arctic, but also to an extent in the Antarctic in the south. Obviously the Arctic is in the north. It's also causing glaciers to melt in particularly places like Greenland. We're also seeing greater temperature differences at the surface of the planet, and this is leading to much more extreme weather events. And there's also a lot of other effects, biological, spread of diseases, and various things that we could talk about that are also related to increases in greenhouse gases and increases in global temperatures. So this part of the course fits in really well with the science as a human endeavour, or the SHE strand of the course. So whether it's in the science as a human endeavour assignment, and we're still looking exactly at what we will base that on, or I'm still considering that, but also you will have from time to time through your tests and in your final exam, science as a human endeavour questions. And this is one area that you could expect that is probably a really good area to look at with that science as a human endeavour focus. Thank you.